is such a beautiful person. So I'm so happy we can have him as a speaker today. So I made you blush long enough. I'm going to let you do your talk now. So please give a round of applause for him.
Okay, how's everyone doing? Because I was just coding pagination going on the stage, and this is not a good idea, I can tell you. I hope everyone's doing okay. I know it's afternoon and the energy levels are probably going down, but for me, I couldn't be more energized and kind of happy to be here because I was on the first NGBE conference in 2016, and I remember the energy and remember what Carmen did that time. I did remember that she played my favorite song after my... and I wanted always to get back because the feeling was so good, like things didn't align. But I'm here today, so I guess some of the dreams come true. But I wouldn't be here today, nor in 2016, if not for this one line of code, this code snippet here. So around 2010, Miško came up with this idea of AngularJS, and I got absolutely hooked on this one line of code. It was concise, it was powerful, I could do things in a way that were not possible or very awkward previously. And really, this one line of code made me AngularJS developer. It really made me Angular developer, it changed my career, it really changed my life. So this was concise and powerful, but most importantly, it was new. It was something that was this new radical idea that we can think or rethink how we're doing UIs, that we can embed the rules of the game of our UI in the model and then have some type of templating language that will map our model to what browser needs to display. That was new at the time. And now I don't know how to change the slides because I messed up something, right? Oh, help me here. What's going on here? Can I click? No. Pause. Yes, okay, space works, that should be enough. So I was actually in love with all those concepts, right? Like I was jumping into AngularJS, I was getting all in, and I felt like really like a king of the world. I had it amazing, simple programming model. It felt powerful. It felt like I've got solid architecture. It felt it's like performant. I can do applications. I was really devouring it all. To the point that one day I got digestion's problem, right? And if you had the chance and pleasure of working with AngularJS, you will recognize this error, right? But despite, like, we had to learn about the digest cycles and dirty checking and other quirks of the framework that we probably didn't want to learn about. But despite of all those quirks, we stick to the model because this idea of declarative model that is mapped to the UI is so powerful. It makes thinking about the constructing UIs or using the framework so much better. So over the years, we learned how to work with those systems. We learned about the unidirectional data flow, and we also learned what happens if we don't follow the rules. We learned about the pure pipes because we know that those pure pipes are more performant than the ones that execute over and over again. But we also had to learn about immutable data because this is how the pipe recognizes that argument change and actually needs to execute. We learned about the on-push change detection because even if we do change detection only once on the entire component tree, still if the component tree is big, we might just want to change the text selected set of components instead of an entire tree. And by the way, we also learned about the RxJS and async pipes because this became a de facto standard by which we can tell the framework that actually our on-push component changed. Those are great learnings, and I guess we just grown up. And over the years, we became the adults that it's our broccoli and fruits instead of fries. We learn and study hard. We exercise our memory muscles by knowing which map operator to apply in certain situation. But as my manager that sits here, sometimes there's this child in us that says, like, can stay in the middle of the cookie aisle in the shop and say, "Je veux des bonbons." Like, I want my candies now. because this is good stuff, because I did so much enjoy it. So I guess I should have titled this talk as How to Enjoy Belgian Chocolates Without Feeling Guilty, but I've settled on something more boring, which is reactive Angular. So when we say reactive Angular, like, I guess the first reaction will be, what do you really mean, right? Like, aren't we reactive already? We are using reactive extensions. We are using RxJS. We are already as reactive as we can be. Or maybe you want to turn Angular into React, right? Like there is this. Or maybe you want me to read academic papers about functional reactive programming or whatnot. So for the sake of confusing everyone, I will introduce my own definition here for this talk. And when I think about the reactive framework, I'm thinking about the data, or how we embed rules for the data so we understand how the model flows through the applications, where model lives, how it's connected to different parts of applications, and which components read this model. And by doing this, introducing these rules, I can have my component tree somewhere on the left. I might have my model somewhere on in the services on the right. And if I could only draw those yellow arrows here, I would know that, oh, if this piece of the model changes, I need to probably recompute this other model here. And I need to go to the components that actually read this model and update, right? Like, I precisely know where my model lives, who depends on whom, and what I need to refresh as the result. Or maybe hydrate, I don't know. Or no, resume, I'm sorry. So if we can get those arrows, the yellow arrows that we will be fighting for today, we actually getting some clarity about how data lives in our application and how it flows through our applications. And to some degree, we do have it with observables. Apparently, they are just hard to read after half a year. Again, the arrows will give us some clarity, but also better performance because we know which part of the data is accessed where. So one way of drawing those yellow arrows is by doing signals. Apparently, it is an elephant in the room. I thought it's more like a traffic light thing, you know. So what is a signal? Another definition, let's confuse everyone, including myself. It's a value that can notify us that it changed. And this notification is delivered synchronously. Definition aside, let's use a better mental model, which is a box. A signal is a box. It's a special box in certain ways. It always has something inside, which is good, right? Like, it's disappointing when you look inside the box and there is nothing. This one always has something. It has other magical property that if you exchange an item in a box, it will raise a hand and say, like, you know, I've got something here. You can open it up and look inside. You don't have to. But the box is saying, hey, I'm signaling that there is something inside. So from pictures to code, how do we create signals in the code? There is the signal API that we are exploring. You can create a box with this initial value by calling the signal operation. Again, this box is very forgiving. It can be very small, have just a number value inside, or can be entire JSON data that you just pulled from the server. The box couldn't care less. You can open it anytime you want. It will have the current value. It has no opening a box has no consequences. You can close it again and open it up. Nothing bad happens. Then, like just getter is opening a box. Now we also have the set and update operations, and the set operation is really saying like, oh, I'm just exchanging the content of the box. The set is really the primary operation. I kind of half regret that we introduced the other one, which is called update. which is a convenience function, right? Like it is just taking the current value in a box and exchanging it with some mapping. But again, the only primary operation is a set. Okay. We do have these green boxes, and they are not super interesting on their own, but it allows us to build other boxes. And the other type of box that we are going to build is computed, which has interest definition of declarative derived state plus dependency tracking. I don't really know what it means, but if we go from definition to a picture, maybe things will be a bit more clear. So the computed is the yellow box. And as Simona said today, it's a creepy box because it looks very intensely at other boxes. And it does so because if one of the green boxes is like, hey, I've got something, the creepy box will say like, okay, I've noticed. It will do some work, and it will derive a new value. And it will say, well, now I've got a value. As Simona said again, this is not very creative box because it just looks at others and recombines what others have. This box is also lazy because the actual work happens on demand. So we've got a creepy, not very creative, and lazy box. Well, it happens. It's still very powerful, so we like it. So how do I create yellow boxes? Hey, I just got computed API to which I supply a function, which is a real work that should execute depending on dependencies or green boxes. So really, by using or referencing another signal here, I'm just like setting aside on whatever is interesting to me, and the actual work that gets executed is this entire function. Now, computed, they might look bizarre in the sense like, why do you want me to wrap some operation in a function? Well, because this function will execute every time the dependency is changed. It has a set of guarantees. It will not be executed randomly, but it will build a graph of dependencies, this kind of lines of sight, and will execute only when the dependency is changed. So it's a nice property. Yellow boxes being boxes can observe other boxes, so we start to build this chain of computations, right? And we build connections in the system, so we start to understand how they, where data lives and how data computes as the data change. And this is our yellow arrows that we were fighting for. So here's an example of the signals used in an Angular component. You can see at this like two-stage derivations where one computed depends on another computed. The first computed is intensely looking at the counter to derive its even value. There is some example of color that is computed that is looking at the is event. So we're building the chain. This can be as deep as we want. There are no limitations here. Cool. The cool property of the system is that the component boundaries are not blocking this observation mechanism. I can see through the component boundaries, which means that I can pull out a piece of state that I initially had in my component and transfer it anywhere I want. I can put it in a service. I can put it in any other random place in my application where it makes sense. And this is important because I start to use the same primitive. So far, we introduced really two pieces of new concepts, signal and computed, but I can use them anywhere to model my state. It's not like I've got one way of doing state in a component, and then I need to go to some global state management system when I'm jumping out of the component. I'm seamlessly moving through the component boundaries, which means I need to learn only one concept. I can, this observation and like yellow arrows building works all the time, but also it gives me complete freedom of refactoring. I can I can move my code around as I want without changing the philosophy or paradigm and without like really just extracting a code and moving it around. Now, if we build this graph of dependencies, it's a nice exercise in its own, right? Like we like to play with boxes, but like why do it at all? And the main reason is that Angular actually pays attention to this graph. And by paying attention, again, we do have this structure of data, how it flows, and Angular can make use of them. So we can think of the Angular template as something, another, I guess, creepy creature that looks at everything that is accessed in a template. Right? It will say, like, it kind of will make a mental note of all the signals that are being accessed in a template. And if one of the dependent signals changes, it will say like, okay, the part of the data model changed, and I'm using it in a component, so now I know, first of all, that something changed, but I also perfectly know who is reading this, which means that I can now schedule this component and only this component for refresh. Right? I can go down to the component level. I don't need to traverse the component tree from the top to actually understand what changed. And for this system to work, for the system of refreshing or resumability or whatever other information we know from this change notification, there is only one rule that you just access as signal in template, right? There's no explicit subscription, there is no async pipe, there is no cleanup, nothing. You just access the value. Again, since I know who is interested in a change, I can do per component change detection. That's great. Also, I don't need a system of on-push change detection, right? Like I perfectly know who is accessing what. I know that it changed, so I don't have a special rules for the component. I guess that's the nice property. The other nice property is that it opens doors to optional Zone.js. Because currently the Zone.js acts as the notification mechanism, right? Like it kind of tells the framework that something changed in a browser, that there was an event or maybe network response, and some state of the application might have changed. But that's about it that we get from Zone.js. When you set a signal, when you kind of put something in a green box, then we've got much more precise information. We know that something changed. We know how this data travels through the application. So that's another nice property. Now, so far we're talking about how Angular is paying attention to the graph. But we do want to teach Angular how to speak in signals back to you. And one of the most requested features for the framework is having some sort of reactive inputs, right? Like in the previous talk, we're saying like, oh, if I want to convert from the current inputs and down to the observable world, now I need to use either ng changes or setters or do other special tricks to actually jump from this imperative word to the reactive word. With introduction of signals as the reactive primitive inside the framework, we can think of modeling signals or modeling input as signals. And again, in the grand tradition of introducing new syntax pieces of snowmans, I don't know what the syntax for those signal input is. We do have some proposals, and I will talk about them in a sec. But essentially, you can say like, hey, like this input should be exposed to the component as the signal. Now, as soon as it is exposed in the component as signal, I can use all the other reactive primitives on top of it, right? Like, here's an example of the some to-do list where I'm getting a list, I'm getting a filtering criteria, and I can recompute a new filtered list based on the input changes. Again, this system comes with the guarantees. First of all, this computed will execute only when the dependencies change, when your inputs actually change. And if this snippet or this computed looks similar to NG on changes, then it's kind of rightly so, because it plays exactly the same value, exactly the same role. So we can kind of change the meaning of our lifecycle hooks that are based on change detection to really just use computations and signals. Another thing which is coming up very often when we start about those signals is that we are saying this filtered list is computed here. We are deriving new state or computing new state, and then accessing it in a template as the function call. And I think for the long time in the Angular community, we were having this mantra, hey, like calling functions in a template is not advised because behind the scene, some processing might have happened, and like your performance will go down, or you are going to create side effects. That's not the case here, because as you remember, just the getter function is opening a box and looking what's inside. It's not recomputing new things. So in other words, computed values are like, act as the cache, as memorization, so you can safely access them. And again, I remember many discussions, right? Like if I have to compute the same value twice, how should I do it? Should I like duplicate the same pipe twice, or use view models or whatnot? Now, inputs are probably the obvious framework API to represent as signals, but there are other APIs that perfectly fall into this category of values changing over time that we might want to use in the computed. One of these APIs is queries, right? Like if I've got content children, maybe I'm getting the list of dependent directives, I can derive some state from there. Route params, right? Currently, reading the current value of the route params, I need to subscribe, I need to derive, whatnot. If I just represent them as the getter function that can be used in the computed, it boils down to one function call. Form validation statuses, touched, valid, invalid, perfect example of something that could be represented as signal. There are probably other examples that are not listed there. There are other APIs in the framework, that's the question we are getting also pretty often, that really are not good fit for signals. And I guess HTTP client is a good example here. People asking, okay, what's about HTTP client? Should we convert it to signals? Well, not really, right? Like it is not this concept of the value of the box. It is really more like an eventing system. So it's just to say that there is a set of APIs in the framework that we could look at and say like, okay, does it make sense in the reactive world? Right? All the APIs that actually represent values over time are good candidates for this reactive world. So, kind of to sum it up, I started this talk with this one small code snippet that kind of got me hooked onto UI development. And what we ending up here with is not exactly the same. I've got maybe 3 lines of code, and I've got some parentheses, and I've introduced new concepts. But essentially, I think, we are roughly getting the same joy of use, right? Like I'm just expressing what should happen here in a very concise way without getting all the disadvantages that we had with the previous example, like with the first example. So this brings me joy, and this joy is a side effect of introducing 2 concepts like putting only 2 concepts on a table. So far, we're just seeing signals, value changes over time, again, green boxes, whatnot. we've got computed, just like look at the other boxes or look at the computed, and they can derive state in this very declarative way. Everything gets synchronized in the system. You don't have to worry about how updates propagate. And there is a lot of discussion about what should be the reactive system in the framework, what are desired properties, what are the signals, what are the observables. But looking at this, when we were doing exploration into signals, this system had for us the most of the desirable properties. So this is kind of this pull-based reactive system, which is synchronous, right? So by being synchronous, I know that there will be always a value. If you look at the observables that maybe not have emitted, I might not have a value, which means I need to deal with the null values, potentially deal with the null values in a template. With signals, I don't have those concerns because it's guaranteed to always have a value. Reading a signal in a template is without ceremony, right? Like I don't have to have a explicit subscription in the template in the TypeScript code. I don't have to use the async pipe, and it is true. I have to use this syntax of parentheses, but it's the same rule everywhere. It's the same rule in the TypeScript code, and it's the same rule in my template code. I've got consistent access to those values. The other thing that gives me peace of mind that reading a signal value has no side effects, right? I can always access, I can always look into this box, and I know that there will be no side effects somewhere down the line. So I guess it makes reasoning about the system a bit easier. And again, this I'd like to kind of look at the signals. The only thing I need to do is to read its value. Like there is no special subscription, there is no special cleanup. Now, those desired properties translate somehow into improvements into the framework. So again, we were talking about a lot like how we model the flow of the data throughout the framework, and we make it easier to understand what's going on. We get this new primitive of expressing computation. We've got a map operator, so to speak, or derived or computed operation that allows us to synchronize data in a very easy way. I don't need to worry about combined lattice. I don't need to worry about glitches. We could potentially replace some of these concepts with just computations. And finally, we can improve performance, but making Zone.js optional by doing change detection per component. And maybe one day using this notification signal to resume components that were rendered on the server side. So, I was talking about it as okay, this is done, signals there, we've changed the framework, we modified all the APIs, and it's all beautiful. Well, in reality, this is exploration work, right? Like the exploration work that we started about 6 months or maybe 9 months ago, we were digging into various reactivity systems. We were writing proof of concepts, demo applications, and whatnot. So where we are today is the state where we said, that probably makes sense to us as the concept and as the evolution of the framework. That's why a couple of weeks ago, you've seen a discussion of pre-RFC where we announced, hey, we are exploring signals as the reactive primitive in the framework. There was very animated and detailed discussions. We had over 650 comments, very interesting takes. But based on this discussion, we say, okay, we hear the questions. That's good. We want to address them in the real RFC by laying out our thinking and addressing all the questions that were raised. So we are planning of having public RFC on both what signals are on all the API surface and how they fit into the framework. Now, depending on the feedback on the RFC, and if we decide to move on with those concepts, we have a rough plan of introducing a signal library in v16. We actually checked in like a demo implementation so people can experiment with those APIs. The other changes that we would do in v16 is using signals to mark components for check or whatnot. Like, we will have details in the RFC. But in v17, we would really do those deeper changes in the framework where inputs become reactive, where change detection can run per component, and where really the framework fully understands reactivity. So that's the rough plan. Obviously, with the changes like this, with introduction of new concepts, of the new ways of doing things, there is always a question of backward compatibility. And I think we learned our lesson, and our default thinking right now is that all the changes that we are doing are backward compatible and interoperable with the rest of the system. So if you see the value of going with signals with these new reactive primitives, those components that take full advantage of signals should be perfectly working side by side of the zone-based components. Now, what can you do today? Well, first of all, we can chat anytime about signals after the talk or in the afternoon. But as I mentioned, in a few weeks, we are going to have public RFC, which is, I can tell you, pretty long and pretty detailed. So I would, if you are into those topics, I would encourage everyone to kind of read through it. And if there are parts that are still not well explained, not well covered, you can absolutely engage on this RFC. We are going to have open discussion. And all the questions on the table, we're always saying that we prefer, we want to get those things out early. So if we discover things or you discover things that, where we should change direction, change design, or adjust design, we want to know about it early. We want to know about it on a paper and not in v17 after implementing things. We can see more and more prototypes. Again, we checked in the signal library into repository so people can experiment with them. And what we see as well is that state management libraries are starting to experiment with the signals. We've got people from NGRX, from RX Angular, from NGXS, actually having public RFC of how the state management could look like if we take advantage of the signals. So if you are a maintainer of a library and you see something here that looks interesting, I would encourage you to have a look and play with those things. And I've got exactly 4 minutes to say thank you, but also to show the code that I was frantically coding when the previous talk was in progress. So, obviously it's a good example for signals because it's very synchronous, but it also shows some desired properties of the system, right? Like we've got, I hope that I kind of coded it somewhat resembling what was being presented, but let's say we've got these 3 signals, like just, green boxes. I've got number of items in the collection. I want to have a number of items per page and this current selected page index. And again, those are our green boxes. Those could be inputs. Those could be local state. I don't know. Those are signals. And based on those, I can derive the rest of the information that I need in this template. So obviously, number of pages here, this is this complex logic with the math ceiling here. And I can decide if those buttons are previous and next buttons are disabled. I guess it's pretty concise. It's just one operator here that I've got. Now, the other thing that you can see here is that accessing those signals in a template is pretty stress-free. We are not seeing async pipes here. I don't have to care about the default values or null values because boxes always have values. That's all I've got for today. Thank you.